Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps webinar. I am Charlene O'Hanlon, Managing Editor and Moderator for today's event, and I welcome you. We have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following the webinar, we will be sending out an email that contains a link to access the webinar on demand. We are also taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also happening at the end of today's webinar, we will be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, let's get right to this webinar. I'm super excited about this one. It is called Responding to Chaos with PagerDuty and Gremlin, also known as the Psychology of Chaos Engineering. And our speaker today is Julie Gunderson, who's a DevOps advocate at PagerDuty. Julie, thanks so much for joining me today. Really appreciate it.
Thank you. And thank you everybody for being here. Happy Tuesday to everybody. As Charlene mentioned, I'm a DevOps advocate at PagerDuty, and I'm really excited to be here with you all today. So we're going to talk a little bit about the psychology of chaos engineering. And the slide that you saw when you came in is an event that PagerDuty and Gremlin are running together on the 28th of January, which is a 3-hour interactive workshop where we can put a lot of the things that we're going to talk about today in practice. So feel free to join. It's free, and I'll pop that QR code up at the end. So when we talk about chaos engineering, I popped a question on Twitter, which was wrong answers only. What is chaos engineering? And Isaac, what some engineers do every day, but don't know they're doing it. And then all the answers started coming in. The new practice that will save us all, keeping your coworkers on your toes from Jason Yee. There were a lot of things like breaking production for fun. When people think about chaos engineering, and yes, I have this at wrong answers only, but unfortunately with the wrong answers only, these are oftentimes the answers that people think of when they think about, well, what is chaos engineering, when they hear about it for the first couple of times. So when we talk about chaos engineering is the discipline of experimenting on a system in order to build confidence in the system's capability to withstand turbulent conditions in production. And where chaos came from, there's a lot of differences of opinion here. When people first became aware of chaos engineering, it was from Netflix. They have this tool called Chaos Monkey. And the intent of Chaos Monkey is it would shut off services in production, which really created this need for defensive coding, because in reality, systems are turbulent, and it's really not if, it's when systems are going to go down. And now it's morphed into more than just shutting things off. And chaos engineering is really about experimenting. So chaos engineering is about building a culture of resilience in the presence of unexpected system outcomes. It's not about the tools. They're really just the means to the end. It's about the experiment. So you can take a look at what Sidney Dekker has to say about resilience engineering. Sidney Dekker says resilience engineering is about identifying and then enhancing the positive capabilities of people and organizations that allow them to adapt effectively and safely under varying conditions. So let's talk about what chaos engineering is not. And when I ask, what is chaos engineering to you? I mean, think about that. And I'd love it if you want to pop some of your thoughts into the chat. People often say, isn't all engineering chaotic? A lot of people are not aware of the practice of chaos engineering. And again, chaos engineering is not about breaking things. It's not about trying to figure out how we can make things fail. It's not about engineering being chaotic or processes being unpredictable. There's a lot of work that we do that's unfortunately named, and chaos engineering is one of those. So we don't need to take chaos literally. When we talk about chaos engineering, It's about experimentation. So we're creating a hypothesis. We're saying that we believe that if a certain thing happens, this is what's going to happen to our system. We believe our system is reliable. We don't want to just go in and say, let's just turn some things off. Let's see how we can break stuff. We have to have a hypothesis, because if you don't have a hypothesis, then how do you know if you were right? How do you know what you learned? We talk about efficient and effective organizations being learning organizations, and chaos engineering is an effective tool for learning more. At PagerDuty, we say that incidents are a gift. As humans, we can't talk to our systems directly. We have to communicate through a proxy. So an incident is, in a way, our system's way to tell us something. Now, what's better is if we don't have to wait for an incident, if there's a way that we can encourage our systems to tell us things about themselves so that we can learn more. And so we do this by creating a hypothesis and then testing them. So when we talk about experimentation and chaos experiments, some people, they say that you have to run your experiments in production. However, and I'll chat about this a little later, not all systems are appropriate for production testing. So while running in prod is preferred, it's not required. Now, there's no testing like testing in production, because no matter how good you think your staging is not production. You don't have things like a Google bot crawling you in staging. You don't have some random Blu-ray player from like 6 years ago that's trying to run your client in staging. But testing in production comes with risks. So Charity Majors over at Honeycomb, she said, nines don't matter if your users aren't happy. And the reason I bring this up is to remember that we live in a world of scale. So we understand that chasing 100% reliability is a fool's errand. So we say, what's the minimum acceptable uptime? Is it 3 nines or 4 nines? But there's still a human on the other end of that 0.001. People that are still trying to do something. And when we think about chaos engineering, we want to think about the impact to them, to that person. And that doesn't mean that we shouldn't experiment and test in production. It means that we need to be equipped, because I'm going to tell you that if you say you aren't running experiments in production, you really are. They're just really crappy designed experiments. And so the better control and better understanding we can have, the more resilient our systems and teams can become. And so think about observability. We're doing experiments, and we have to be able to understand the impact of what we're doing. We have to understand when we need to pull back an experiment. Maybe we hit a gate that says this is too much because we have a hypothesis, but what happens when we prove our hypothesis false? I mean, our hypothesis, it might be that if we shut down this particular system, or our circuit breaker will kick in and people will still be able to watch their movie. But what happens if they can't watch their movie? We have to be able to back out of that, or we need to be able to work around it. We have to have an understanding of our system and what the user experience is like. So we want to measure things like the impact of downtime. You also want to minimize your blast radius, and there are lots of ways to do this. So canaries are a great technique when running chaos experience. And just like I talked about running in production, it doesn't mean that you're going to run against all of production. You want to have an understandable blast radius. And there's another way to think about blast radius. It's more about releasing, but it's something to consider. So if you look at how Microsoft releases software, they have this notion of rings. There are these concentric circles that start out where the first is just being released to the people who worked on the product. And then they start to roll it out to other teams inside of Microsoft. And then eventually to all of Microsoft, and then consumers. And what's happening is that as they learn more as the software is being released, they're able to expand that blast radius. And you can do the same thing with chaos experiments. So you can say, first, I'm going to run this against 1% of production because I don't know anything yet. I only have the beginnings of my hypothesis. And then maybe you say, okay, looks like I might have been right. It might be okay. Let's test it a little bit more, and then let's test it a bit more, because that way, if you're having a scenario that's causing a degraded customer experience, you're minimizing the number of people who are being affected. And this is at the core of all of this. We have to remember that we have users, we have people who use our product, and it's really easy to like work at the scale that we work at and just look at the ones and the zeros and forget about the people on the other end. But there's someone that's sitting there that's possibly having a bad day, and we want to minimize that risk. So when you're designing your thoughtful experiments, there's a few things that you want to think through. So you first want to start with documenting the expected behavior. What are you expecting to happen? And then what are the potentials or for possible failures? And actually, we did a podcast with Bruce Wong over at Stitch Fix, which you can find at pageittothelimit.com, where we actually talk about designing some tabletop experiments so that you can think through some of these things without ever touching your systems. And so you can kind of map out and think, what are the possible failures? Then when you've done your experiment, what was the observed behavior? And you do want to pick a time that the stakes are lower with minimal impact. Like, you don't want to do this if you're a retailer on Black Friday. You want to think through when your experiment is going to happen. And you want to keep that audit trail of events. So how did everything go? What was the order of events? And then what's really important is to also review the notification and response process. And this is something I'll talk a little bit more about. But at PagerDuty, when we talk about incident response, we use chaos engineering as a way to train new incident responders, but also practice that response. Did our alerts fire? Was all the monitoring working? How did people gather? Is there anything that needs to be refined? So we practice Failure Fridays at PagerDuty because alliteration is very important. And when we do this, we uncover implementation issues that reduce our resiliency. And what we're looking to do is proactively discover deficiencies to avoid these discrepancies becoming a root cause or contributing factors for future outages. Chaos engineering and Failure Fridays at PagerDuty, it really builds a strong team culture, because by coming together as a team once a week, we're sharing knowledge. Ops can learn how the dev teams debug production issues in their systems. Devs gain a better understanding of how their software is deployed. And it's a really nice perk to train new hires on how to handle outages at 11 a.m. on a Friday versus 3 a.m. on a Saturday. This also reminds us that failure will happen. Failure is no longer just considered a freak occurrence that can be ignored and explained away. All code that the engineering teams write is now tested against how it's going to survive that Failure Friday. And in 2013, that's when we actually started practicing Failure Fridays. And we had our first Failure Friday, and we learned a lot over the years. So we started out manually, and after about 33 sessions, we finally automated a lot of the manual commands from the original Failure Friday. By doing the steps manually at first, we validated and learned from them without having to spend a lot of that time up front. And as we grew as a company, it became more difficult to ramp up new folks. So we enlisted the help of our company bot. And we realized that Failure Fridays were a great opportunity to exercise our incident response process. So as I mentioned, we started using it as a training ground for our newest incident commanders before they graduated. And as we started to scale up the number of services and teams maintaining them, we started to keep more formal documentation on planned faults and checklists for future sessions, outcomes of faults, and so on. And I mean, if you think about it, it's really not science unless you write it down. Now, years later, we began simulating failover to our disaster recovery infrastructure. During normal operations, we validate our DR tooling with a small percentage of live traffic, but during these scenarios, we ramp up the percentage of that live traffic, taking care not to impact our customers. And so we learned a lot that injecting failure and continuously improving your infrastructure it's not only helped us deliver better software, but building internal trust and empathy. Stress testing our systems and processes help us understand how to improve our operations, and you can do it too. And when we talk about building trust and empathy, you don't want to forget about the people. We understand, and it's been proven that following these chaos engineering techniques will let us understand our systems better. It will cause us to build more reliable and more stable systems that will help us build more resiliency into our organization and into our things. And that's great and good for all the computers and your networks and all the things, but what about your people? And one of the tweets, I think it was from Jason Yee, I think he said that the wrong answer was keeping people, your coworkers, on their toes. We're not looking to test your people. Again, that doesn't build trust. So we want to let people know ahead of time when a chaos engineering experiment is scheduled. It's not about catching people off guard. These are planned. So the thing is that you've all experienced it. You may just not have known it. Most people seem to be okay with Netflix practicing chaos engineering. I mean, I think we've seen this, oh, we can't load that title right now. You hit reload and it's there. And when Netflix does this, it's great because it means they know their system. I'm not going to miss out on Stranger Things or Bridgerton. But how does it make you feel when it's your bank? And when your bank practices chaos engineering, it's quite a bit different from when we can't play this title right now. I mean, you might be trying to pay a bill or transfer money or do something critical. And then now how do you feel? So thinking through that, does that mean that financial institutions and other industries like that should not practice chaos engineering? Yeah, absolutely not. In fact, it's absolutely necessary. But when you're practicing these hypotheses, you have to remember that you're teaching your organization how to fail gracefully, how to understand retries, how to do these things. And so that's when you start small. And this is why for a system like this, maybe you don't start testing out in production because you know what, you're just not sure. At PagerDuty, we actually have some systems that we don't run Failure Fridays on in production scenarios, which is part of the hypothesis that I don't think that this system is as resilient. So we're going to go ahead and practice this in testing. And so as I mentioned, we had this podcast with Bruce Wong over at Stitch Fix. And one of my favorite quotes from him is that saying you're getting your systems ready for chaos engineering is like saying you're getting in shape to go to the gym. You can buy gym shoes and shirts and shorts, but at the end of the day, you just have to go to the gym. You don't get in shape first. And the same thing applies to chaos engineering. You need to design your experiments and have your hypothesis. You also need to think about the organizational culture. But at some point, you just have to jump right in. So whether or not it's in staging or whether or not it's in production, you just need to do it. So thinking through that, can you think of some times that, like some chaos engineering experiments that maybe you've done that hadn't been thought through enough or could have been thought through better, or the things that you learned? Because even as you're doing these experiments, it's an iterative process. And I say on a lot of my talks, make sure that you own your processes and that they don't own you. And the same applies to chaos engineering. However, I've also mentioned that sometimes things have unfortunate names. And it turns out that C-suite folks, CFOs, they don't love the word chaos. They especially don't like the word failure. So you do want to think about, what are you going to call this? And you can use things like education experiments or learning, words like that. Think about the words that we use and the weight that they carry. And we should really think about this anytime we're talking about a transformative change, because we may know what chaos means. We may know what these terms mean because we get the benefit of attending webinars and attending conferences and talking to our coworkers. But CFOs, they might just hear you want to inject failure. So you need to help them understand. And with that, you might really need to change your nomenclature, because management, they can get nervous. And so when you're starting chaos engineering, it's also about being able to explain the philosophy to your leadership, being able to explain to them the blast radius that we talked about, how you can minimize impact, how you've thought through the impact on the people and the customers, and the goal to build more resilient systems and a company with a stronger trust culture and an empathy culture. Because it really is all about that philosophy. I talk a lot within incident response about the mentality shift that needs to happen when we're in a wartime or a not okay versus okay mode. And there's still a mental and philosophical shift that needs to happen when you're embracing and learning from these types of techniques. It's not just about turning on Chaos Monkey. It's not just about doing these things. You've got to really consider the organizational culture. And you want to think about the culprit culture. And remember, you can't just change culture overnight. We all wish we could just snap our fingers and say that it's changed. But you can start changing behavior, because behavior influences culture. So think about incentives, because incentives are one way to change behavior. Think about how you can incent people and how you're incenting people to participate and embrace this. And this goes back to blameless cultures as well. Because as I mentioned, when we talk about chaos engineering, we talk about demystifying failures, embracing failures as learning opportunities. And chaos engineering is one of those great ways to help bring that blameless culture to your organization, because we're learning from our failures. Now, before a Failure Friday begins at PagerDuty, it's important that we make an agenda of all the failures that we wish to introduce. So we schedule a 1-hour meeting and we work on as many issues as we can. Injecting failure, it may cause a more severe failure than we'd like. So it's important that everyone on the team buys into this idea of introducing failure into the system. And so to mitigate this risk, we make sure that everyone on the team is notified and on board. Because again, as I mentioned, it's not about testing your people. This is about testing your systems. And as we prepare for the first attack, like we disable any cron jobs that are scheduled to run during the hour. The team whose service we're going to attack, they're going to be readied with dashboards to monitor their systems as the failure is being injected. And communication, it's so imperative during chaos engineering experiments. At PagerDuty, we use a dedicated room and a conference call so that we can exchange information quickly. So we use Slack, and having that Slack room, it's especially useful because it gives us a time-stamped log of actions taken, which then we can correlate against the metrics that we capture. So just like during an incident where we have an incident commander, a deputy, and a scribe, the scribe here in chaos engineering experiments is really important because they're capturing what's going on, the decisions that are being made. We also keep our PagerDuty alerts turned on because we want to confirm that we're receiving alerts, and we want to see how quickly those alerts arrive in relation to the failure that's being introduced, because that's part of what we're testing. So you can take a look at this example. Cody felt excitement over a new error that hadn't occurred before. So one way is to give junior developers more freedom to do things. These are great people to get involved in your chaos engineering experiments, because those of us who've been doing this for a long time, we get stuck in these thinking patterns and we start thinking about things in certain ways. But new people, interns, junior people, they may ask a lot of questions, and they're going to ask different types of questions because they may want to get things done in a different way. Because when you've been doing something for years, you've maybe just always done it that way, and it might have worked out, but that new set of eyes and that new way of thinking, that can really make all the difference. Now, safety matters, and I talked about this with minimizing the blast radius and minimizing the impact. You want to go into these things eyes wide open. You want to think about what the impact is, and you want to think about very specific things. So, for example, you want to know what your key metrics are. Going back to Netflix, they have one very key metric, which is stream starts per second. And as far as Netflix is concerned, this is the only thing that matters when they're running chaos experiments. If they see this drop, that's when they might pull the plug. So think about, what are your conditions for shutting down your experiment? And you want to keep it somewhat simple. If you have 15 key most important metrics, that's too many. And I'll mention it again. This is not about causing stress on your people. This is not about getting people used to stressful situations. Instead, you want to be as transparent as possible. You do not want to run experiments without affected people being aware. Your on-call needs to know that experiments are running. So be transparent. You're not trying to catch people and trick them. And remember that when you're designing these experiments, there are humans on the other end of those numbers. And they may be people that are paying for your service or trying to use your service. And you don't want to lose sight of the people. Your coworkers are also people who are trying to do their job, and you're injecting change. So also remember those human factors. And going back to the conditions, write those conditions down, share them widely with folks in the company so that they know what they are. And just some key concepts to think through. So you want to build a hypothesis around a steady state behavior. You want to focus on that measurable outcome of a system rather than the internal attributes of a system. Measurements that output over a short period of time, they constitute a proxy for that system's steady state and the overall system's throughputs, error rates, latency percentiles. They could all be metrics of interest when representing that steady state behavior. And by focusing on systematic behavior patterns during experiments, chaos engineering, it verifies that the system does work rather than trying to validate how it works. You also want to vary real world events, right? You want to prioritize events either by potential impact or estimated frequency. Consider events that correspond to hardware failures like servers dying, or software failures like malformed responses, and non-failure events like a spike in traffic or a scaling event. Any event capable of disrupting steady state is a potential variable in a chaos experiment. As I mentioned earlier, try to run your experiments in production. Systems behave differently depending on the environment and on those traffic patterns. And so if you feel that your system is reliable enough to run it in production, do start there. But again, remember that you don't have to run against all of production, maybe 1% of production or 5% of production. Going back to that minimizing the blast radius, you can roll this out. And then automate experiments to run continuously. Running experiments manually, it's labor intensive, and it's a great way to start if you're new to chaos engineering. As I mentioned in 2013, when we started with Failure Fridays at PagerDuty, we ran all of our experiments manually. But as we got more into it, we started automating away some of those manual tasks. And then minimizing the blast radius. I've talked about this a lot. That's one of the key elements because you are thinking about the people on the other end. And knowing when to pull the plug on your experiment, knowing when to roll it back, and having those things identified ahead of time before your experiment are key elements to having a successful experiment. And then there's also quite a few helpful tools. There's the Netflix Simian Army, which is found on GitHub, and that's the collection of tools Netflix uses for their chaos experiments. Gremlin, who this is part of one of Gremlin's series, they have both a paid and free version. And they've got a lot of great information about how to approach chaos. And there's also the toolkit. There are some great places to get started to look at what you can do and how you can practice some of these chaos engineering experiments. And you want to think about, do you have a formalized chaos engineering practice? A lot of organizations have informal practices. They can be very informal. You don't have to do them on Fridays like we do at PagerDuty. But one of the reasons that we do it on Fridays is we do our experiments on Fridays after everybody has returned from lunch. People are in the office, they're there, it's on a calendar, it's planned. People know that this is going to happen. We like to do these during work hours. 3 a.m. is not the best time to practice chaos engineering, but also remember to look at your response process. Did your incident response process work as expected? Did all your alerts fire? Did your monitoring catch things? Look at all of your systems. And then, as I mentioned, Gremlin and PagerDuty were doing a joint workshop responding to chaos with PagerDuty and Gremlin. And in that workshop, we're going to be practicing both the incident response process and chaos engineering by injecting some failures into systems and teaching people how to work with their organization to have a smooth process moving forward. So feel free to join this. This is actually a 3-hour workshop and it's on January 28th, and we're really excited to do this together. And then I did want to open it up for questions.
All right, let me get back on camera here. Looks like we have gotten some questions in, but there is plenty of time. If you have a question for Julie, go ahead and use your GoToWebinar control panel, and let's go ahead and take a look at what we've gotten in so far. Let's see. Okay, by making your production potentially fail, you impact your SLA, right? How does the SRE take it? Do you manage to control the failure in a way that does not affect the services fully?
Yeah, that's again the thing about going back and not testing against all of production or understanding when you're going to pull the plug. I mean, you definitely don't want to impact your SLOs and SLAs. So you want to understand what systems you're impacting, and also you should be probably doing this with your SRE teams. They should be fully aware. But if you start to impact those, that's when you want to go ahead and pull back.
Okay.
On your.
Right. Go ahead. I'm sorry.
Oh no, pull back
I didn't mean to correct
on your process.
Okay. All right. Great. So next question. Let's see. I think he's talking about where was this podcast aired? What's the name of the channel? You were talking about a podcast in your conversation?
Oh yeah, the podcast we did with Bruce Wong over at Stitch Fix, and he used to be over at Netflix. So that's at pageittothelimit.com. And it's with Bruce Wong, and I feel like it was a little bit earlier in the year, in 2020. I'm sorry, I'm still confused at what year it is. So you can definitely find it over there. It's also posted in community.pagerduty.com because this is our chaos engineering week of 30 days of DevOps. So we're having a little bit of fun there.
Awesome. All right, great. Let's see. So many great questions have come in. I'm super excited. Okay. How can you kickstart doing chaos engineering in a company that is afraid to fail, or even convince management that this is positive? And how do you make people buy in? It seems to be the biggest question of ever.
So, you know what? I get that one a lot, right? How do you start? And so you can start this small. A lot of companies are afraid to fail. That's why I talked about like what the language that matters is. So first of all, companies that are afraid to fail, maybe don't call it chaos engineering, but you can start out small. You want to go ahead and prove the ROI, right? So what did you get out of this? So go ahead and maybe start small, start in testing, be able to show your organization that you've learned from this and you're going to be able to prevent a systems-wide outage or a lot of downtime because you're able to see the investment that taking the time to test your systems will have on the future outcome. And so what I would really recommend there is start super small, start in testing, make sure that you communicate clearly and probably stay away from the term chaos. Also though, we've talked about organizational culture, and companies that are afraid to fail doesn't mean that failure won't happen. Being able to explain how turning your organization into a learning organization helps with it. We talk about it in operational and organizational maturity. Organizations that are operationally mature tend to be learning organizations, so they learn from their failures, they practice postmortems, they're very blameless. You want to go back and kind of explain that to your organization because, as I mentioned, it's not if systems are going to fail, it's when they're going to fail. So being afraid of them doesn't mean that they're not going to fail.
All right. All right, great. Plenty of time for questions, guys. If you have one for Julie, go ahead and use your GoToWebinar control panel. And you just answered the next question I had for you, Julie, which was, can you go back a slide and show the QR code? So thank you. And I'm sure Tan thanks you as well for doing that. Okay, let's go ahead and move on. Next question, what is the additional value that chaos engineering brings over disaster recovery testing?
Because when you're running chaos engineering, like in an environment, you want to be able to like simulate that behavior. So when we talk about disaster recovery, did everything fail over the way it was supposed to? We had at a previous job, we had a rather large outage. Everything went down. We had to go over to the data center. Our people actually weren't able to get into the data center. So that caused quite a big problem. So did everything work with your disaster recovery planning? Were you able to then additionally bring those systems back up? I hope that answers that question, and I can delve more into it. And I think too, Charlene, that the Gremlin folks too, we might send out some answers to these questions.
Okay, yes. So Gremlin is getting a copy of all the questions that came in. So if there are more technical questions or questions we don't get to during the question and answer period, guys, please know that I'm sure somebody from Gremlin will be more than happy to follow up with you offline to get your question answered. Okay, we do have another question here for you. I work in a large enterprise with many different business units involved across a business process. So lots of business units, one business process. Do you have to manage these situations where you work? Do you personally have to manage these situations where you work? And if so, how do you manage it?
You know what? I actually don't have to manage these situations where I work. I'm sorry, Kyle. However, that said, we'll get some information out to you. I'll find somebody at PagerDuty who might have a little bit more advice for you, or we can always find someone over from the Gremlin team.
All right, he sent a big thanks. Okay, next question. Will chaos engineering also help in a large IT estate with a long supply chain? And then there's a, for example, to inject failure, we can turn off applications 5 levels down the supply chain to see what was the impact.
I mean, absolutely. I would say that. I would just say you want to make sure that you have an idea of what you think that impact is going to be. You have an idea of what you think is going to fail. And then you want to make sure that you've let all those different levels know what you're doing so that it doesn't create actual chaos in the supply chain, if that makes sense. So you really want to think through that. And again, it's not just about turning off applications, right? Or causing things to fail. So you would want to design those experiments very, very thoughtfully so that you, again, know when you're going to pull that plug.
Yeah, I would think actually that chaos engineering, those principles actually could be applied to so many other areas of the business beyond just software development or applications or infrastructure. So
I mean,
it's kind of an interesting thought.
Jason Yee and I, Jason over at Gremlin, we also did another podcast together. That's at the pageittothelimit.com. And this was in March or April, it might have been April, right at the beginning of the pandemic. And we were initially going to talk about chaos engineering principles, but actually ended up talking about the pandemic and actually really kind of what that meant for testing our systems. I mean, if we look at how all of these organizations had to scale wildly, right? I mean, look at Netflix. Everybody was at home watching the Tiger King, for example, right? So how do you prepare for these types of events? I mean, nobody thought there was going to be a pandemic, but now we become more proactive and we start thinking through these things in the future. So that's also that was a really fun podcast where we talked about a lot of these principles, but how do they relate to things outside of our technical systems?
Excellent. Okay, well, I'm going to have to check out that podcast because it sounds like a really interesting conversation you guys had. Okay, let's see. Here is another question that just came in, and Fernanda, I think you've got some duplication in this question here. So can you actually resend it? Okay, all right, he did. Okay, how is and I think we already covered this, but how is chaos engineering different from disaster recovery? Is it only about automation, or is there more to it?
I think I'm not 100%. Can you read that to me again?
Yeah. How is chaos engineering different than disaster recovery, which I know you've already answered, but is it
Oh,
only about automation or is there more to it?
it's definitely not only about automation. And I mean, when you look at disaster recovery and DR and how we practice that and prepare for those situations, I mean, they're very, very much so similar. I would say that with disaster recovery, oftentimes we're just planning out those scenarios versus actually doing it and maybe creating those failures, right, that we've thought through and tested out. I hope I'm answering that right, Fernanda, and when we can definitely talk a little bit more offline about that too, because it sounds like you have some very specific questions about DR. So happy to kind of follow up on that. I mean, there are some absolute similarities. I think it's just more about what you're testing and how you're testing it.
All right. All right, great. Well, right now that is all the questions that we've gotten in, but I'm going to go ahead and leave the question and answer period open for just a little bit longer to see if we get any more questions coming in from the audience. But perhaps you can answer while we're waiting, how can a company kind of get started with chaos engineering if they've never done anything before? What are some of the first steps that they can take to kind of get down the road there?
You know, I was just chatting with a friend whose startup went public recently, and I was telling him about this webinar, and I was like, yeah, I'm going to do a webinar on chaos engineering. And he said, what's that? And that actually surprised me for an engineer who's been doing this for about 15 years. So really start by understanding and presenting the basics of what chaos engineering is. And again, as I said, you know, thinking through what you call it. Starting small and understanding that blast radius, making sure that you have these things well thought through. Because one of the best ways to, I sometimes love to go to my boss and say, hey, I want to do this. You just need to trust me, which is great if your boss can just trust you. But when you're talking about potentially impacting revenue, or as somebody else mentioned, SLAs, or your customers, because you trust me might not always be the best way to get something done. So explaining why you want to do this, also being able to showcase some success stories. I can tell you can learn about Failure Fridays at PagerDuty. You can just Google Failure Fridays. I think we're the only ones that use that. Gremlin actually can talk to you also about how to help you design your experiments in a way that helps you learn the most from your systems while minimizing the impact. So really being able to show that you've thought this through, the whys, if you're going to test in production, how are you protected, or why you're testing or why you're practicing chaos engineering in a testing environment. So really, again, as I mentioned, with any cultural change, it doesn't happen overnight. So we want to show the benefits of how this leads us to become organizations that are more blameless and organizations that are those learning organizations.
All right, great. Well, it doesn't look like we've gotten any more questions, and so I'm going to go ahead and close out the question and answer period. And I do want to thank everybody who did submit questions. And as I said before, if we did not discuss your question online, we will be more than happy to follow up with you guys, Gremlin or PagerDuty. They're going to be getting a copy of all of the questions that came in, and Julie, you can tell me for sure, but I am quite certain that they will be more than happy to get those questions answered for those who still have questions or we just didn't get to. So
yeah, absolutely.
Thank you again to everybody who did. All right, awesome. Just a quick reminder that today's event has been recorded. So if you missed any or all of it, or if you just want to watch the presentation again, you'll have the opportunity to do so. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Okay, let's see. Before we close out the webinar today, sorry about that, we do have a drawing that we need to do for $425 Amazon gift cards. So let's go ahead and get that done. Our first winner today is Fernanda. Congratulations, Fernanda. Fernanda M. It's your day today, Fernanda. Second winner today is Jose S. Congratulations, Jose. Third winner is Kyle P. Congratulations, Kyle. And our fourth winner today is Vanessa W. Congratulations, Vanessa. We'll be following up with all four of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see anything there, please check your spam folder. Julie, as always, great presentation. We did have one quick question that did come through. I don't know if you want to, actually that's going to be a Gremlin question, Carlos. We just saw your question. We'll get somebody from Gremlin to answer that question for you offline. So please know that we have seen it, and somebody from Gremlin will get your answer over to you. But Julie, I did want to thank you for a great presentation. Lots of good stuff, and chaos engineering is one of those fascinating topics. I think that everybody can get something out of it, even if they're not actually in the IT or engineering organization. So good stuff. Thanks again.
Thank you.
All right. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.